Last week, you were provided a demo program for creating three-dimensional images. In addition to creating 3D images of the scenery around us using cameras, you can also create artificial 3D images from 2D images. The idea is to align two copies of the same image by a small horizontal displacement. This displacement is often called stereo disparity. Because our two eyes are oriented more or less along a horizontal axis, the displacement should be oriented horizontally, and the disparity cannot be too large. Otherwise, our eyes will not be able to fuse them easily. We can then extract the red channel from the left image and the blue channel from the right image. By adding them up, you will be able to create a three-dimensional image that would float above the background. Here is an illustration of the process that I just described. This is a sample soccer image with the picture of the HAUST campus. If the two images are put side by side, after extracting the red channel from the left image and the blue channel from the right image, by adding them up, you should be able to see the resulting image floating above the background using the red and blue 3D glasses. This is the resulting three-dimensional image. If you use the red and blue glasses, like what I discussed to you last time, you should be able to see the image floating above the background. By using different disparities, you can see three-dimensional images at different depths. In order for you to do that, you will actually need to manipulate the image pixels using loops and arrays, which will be discussed in the next two lectures. For now, I want you to complete a simple program that simply checks that the disparity entered by the user is within certain range so that the disparity is not too large for the resulting image to be fused by the two eyes. I want you to use the branching statements that we have just discussed. This is similar to checking the range of the scores for the course grade program, or checking that you have enough balance in a bank account for withdrawal, or checking for enough gas in your car to make the requested trip. In particular, we want to specify the range to be between 0 and half of the image width. That is, if the input is less than 0, the method will set the disparity value to 0, and you don't see the 3D effect. If the input is larger than half of the image width, the disparity is set to half the image width. After you finish writing a method, you can compile it together with the other method that we have included in the demo package. You can create an instance of the class object by right-clicking on the BouncingBall class, create a new instance. You see that the balls are being displayed on the soccer pitch. From the instance, you can select the animate method. This would ask you to enter the disparity value. Let's first try 20. This is the animation that you will see. If you wear the red and blue 3D glasses, you should be able to see the soccer ball moving towards you. Let's try a larger disparity, say 200, which is larger than the width of the image. The program is supposed to reset the value to half of the image width. And this is what you will see. You can see that the image is moving higher than before. After a couple of weeks, you should be able to generate animations like this by yourself.